Good day, students. In this clip, we're going to be going over some problems and reviewing quadratic functions. So let's take a look at question number one. So question one says, Tina correctly solves x squared minus 12x equals 8 by completing the square. Which expression below would represent the step after the square has been completed? Okay, so you want to recall that completing the square, you have to add b over 2 square. Okay, that's how you complete the square. If you're looking for the x-coordinate of the vertex, x of the vertex, you use negative b over 2a. These are two things that you do not want to get confused, all right? So if you add b over 2 squared to an incomplete square, that completes the square, okay? So let's rewrite the problem. X squared minus 12x equals 8. On the left side, this is an incomplete square, okay? So to complete the square, x squared minus 12x, we have to add a c that makes this a perfect square trinomial, okay? If you add that c value there, you add the same value to the right side of the equation to preserve equality, all right? So in this equation, we can clearly see that b is the coefficient of x, which is negative 12. So what do we do with this value? We divide it by 2, which yields negative 6, and then we square that. Negative 6 squared is 36. So this is the c value that makes this a perfect square trinomial. So let's insert it. We have a 36 there and a 36 here. Now that we have a perfect square trinomial, to factor it is pretty easy. So to factor this, we just read the first and the last term, and then bring down the middle sign, okay? So the factored form is going to be x minus 6 quantity square equals 8 plus 36 is 44. All right, so after completing the square, x minus 6 squared equals 44 will be a correct answer. And as you can see, the answer is option letter B. Okay, let's take a look at problem number 2. It says write the quadratic function y equals x squared plus 2x minus 6 in vertex form. Okay, so we have y equals x squared plus 2x minus 6. We're just going to be completing the square in the x world since this is a quadratic. And remember, the vertex form of a quadratic function can be written as y equals ax minus h squared plus k. Okay, so what I'm going to do first, in order to make it easy for me to create an incomplete square, I'm going to add 6 to both sides. So add 6, and that yields y plus 6 equals x squared plus 2x. All right, now I have an incomplete square here, so to complete this square, I have to do what? I'll have to add b over 2 squared, as we discussed earlier in problem 1. So that has to be added to the right side to have a perfect square trinomial. So x squared plus 2x plus a term that completes the square. Because I'm adding a term to the right side of the equation to preserve equality, I have to add that exact term to the left side of the equation. All right, so let's find out the c value that makes this a perfect square trinomial. So b of x is 2. What do I do with that? I divide it by 2, which is 1. And then when I square it, I get 1. All right, so I'm going to insert the 1 here. So adding 1 to this side of the equation, we have a perfect square trinomial. And I also have to add a 1 here so that I can preserve equality. All right, so let's factor this perfect square trinomial. That's pretty easy to do. You read the first term and the last term and bring down the middle sign. So the factored form is x plus 1 quantity square. On the left side, we have y. 6 plus 1 is 7, y plus 7. And if you look at the options, they all have y isolated. So let's go ahead and isolate y. So to do that, we just subtract 7 from both sides of the equation. And the vertex form of our quadratic function is going to be y equals the quantity x plus 1 squared minus 7. All right, so there goes your final answer. And as we can see, option letter A is the correct answer. All right, let's take a look at question 3. It says which quadratic equations has roots -3 and 8? So we have 6 options here. More than one of these kids could fit this description. So how do we go about approaching this problem? Will it make sense for us to um, find the roots of all 6 by factorization, or is there another way? Well, it turns out that there's another way we can solve this problem. If we have the roots, then we can generate the related quadratic equation that will generate these roots. Okay, so how do we do that? Well, let's write down what the roots are. X equals -3 and x equals 8. So what we're going to do is we're going to work backwards. All right, the steps that yields these roots from a quadratic equation, we're going to reverse them and have the quadratic equation that has these as roots. Okay, so we're going to have this equal to 0. First of all, add 3 to both sides. Then that gives us x plus 3 equals 0. And then in this case, we will subtract 8 from both sides. And then we'll have x minus 8 equals 0. Alright, so now if we use the converse of the zero product property, you can express this as x plus 3 times x minus 8 is equal to 0, since both of them are equal to 0. Alright, now to generate the quadratic equation that has these factors, we just simply do the opposite of factoring, which is to expand. So we're going to FOIL this out, both first, outer, inner, last. When we do that expansion, we're going to have x squared minus 8x plus 3x minus 24, okay, equals 0. The two middle terms are like terms, so we combine them together. So that yields x squared minus 5x minus 24 equals 0. Okay, so this is a quadratic in standard form. So the easiest way to solve this problem is we're going to express every single quadratic in all our options in standard form and see which one matches with this option right here. So let us start with letter A. All right, so for option A, it's x squared minus 24 equals -5x. So to express this in standard form, we just have to make it equal to 0. To accomplish that, we'll add 5x to both sides. And that yields x squared plus 5x minus 24 equals 0. Now, since this doesn't match with this equation, that means the roots of this equation cannot be -3 and 8, okay? Because it's already in standard form and it's completely simplified. So we see that there's a mismatch with the signs. So A does not fit the description. All right, let's shift our attention to part B. Let's shift our attention to part B. Let's test option B out. We have x squared minus 7x minus 21 equals -12x plus 3. So we want to put this in standard form, make it equal to 0, and have each term in all the terms in descending order. So to accomplish that, we'll add 12x to both sides and subtract 3 from both sides. Okay, and that yields x squared minus 7 plus 12 plus 5x minus 21 minus 3 minus 24 equals 0. Okay, so we can see here that we have a match. It matches with B, with the original equation. So this actually has roots of -3 and 8. So B is good, A is no good. All right, let's shift our attention to option C. Option C is already in standard form, simplified completely. And what do we notice? We have a perfect match, so option C is also good. The roots of this one is -3 and 8. How about D? For D, we have x squared plus 5x minus 24. We have a mismatch with the sign of the B. B here is -5, this is +5, so this is no good. All right, let's take a look at option E. Let's write option E in standard form and see if it matches what we want, all right? So let's do it over here. So for option E, we have 1 minus 24 over x squared is equal to 5 over x. To get this in standard form, we're going to multiply the entire equation by the LCD of the three terms. This has a 1 here, so the LCD of 1x squared and x is x squared. So multiply the entire equation by x squared. Okay. Let me box the target equation so we don't get it confused. So that's the target equation right there. All right, so let's distribute x squared to all three terms. So that yields x squared minus 24x squared over x squared minus 5, equals 5x squared over x. When you simplify it, you have x squared minus 24 equals 5x. Okay? And then now we subtract 5x from both sides. Subtract 5x from both sides. And then that yields x squared minus 5x minus 24 equals 0. Oh wow, we have a perfect match. So option E is also an answer. Last but not the least, let's look at F and see if it matches with this equation. If we express it in standard form, x squared minus 7x equals 12x minus 24. So to get this in standard form, we're going to subtract 12x from both sides and add 24. Okay, we'll subtract 12x and add 24. On the left side, we're going to have x squared minus 7x minus 12x is negative 19 minus 19x plus 24 equals 0. Do we have a match? Absolutely not. This is no good. Okay, so we can clearly see that our answers are option C, option B, and option E. Okay, so B, C, E are our options. The other ones do not have the roots -3 and 8. All right, let's take a look at the last question. Question 4. This is the last for trig and pre-calc. So for pre-calc, I'm going to be doing maybe 1 or 2 more problems. Okay, so this is the last for trig and pre-calc. All right, so it says an object is projected into the air with a path described by the quadratic function h of t equals -gt squared plus d0t plus h sub 0, where h is the height in feet at t seconds, g is the force of gravity, d sub 0 is the initial velocity, h sub 0 is the initial height. Babe Ruth hit a baseball that can be approximated by the function h of t is equal to -16t squared plus 80t plus 30. Part A says, what is the maximum height of the baseball? And at what time does it reach its maximum height? So to get the maximum height, h max, this happens at the vertex of the graph that represents the position-time relationship that the ball exhibits while it's in flight. All right, so h max is the y-coordinate of the vertex. Okay, the y-coordinate of the vertex can be computed by inputting the x-coordinate of the vertex into the original function. So we're going to be looking at h of -b over 2a. Okay, so h of -b over 2a will determine the maximum height. Okay, how about the time that it takes the ball to attain its maximum height? The time that takes the ball to attain its maximum height is the x-coordinate of the vertex, and that is determined by computing -b over 2a. Okay, so from this equation, this position function right here, we know that a is coefficient of t squared, which is -16. B is the coefficient of t, which is 80. And c is 3. Okay? Now let's go ahead and find t max first. We're going to find t max first because we see that h max is dependent on t max, or the x-coordinate of the vertex, in order to determine its value. All right, so let's find t max first. So t max is -b over 2a. That's the x-coordinate of the vertex. So it's going to be -80 over 2 times -16, which equals -80 over -32. So the GCF here of these two numbers is 16. So you can divide the top and bottom by 16, divide that by 16. Divide this by 16, so that yields the minuses divide out because minus over minus is plus. So we have, what do we have? We have 5 over 2, which is equal to 2.5 seconds. All right. Okay, now let's take a look at H max. H max is h of negative b over 2a. We've already determined that negative b over 2a is 2.5 seconds, so let's input that into the function. So it's h of 2.5. So h of 2.5 is what you get when you input 2.5 into the position function h of t. Okay, so let's go ahead and do that. So we're going to have negative 16 times 2.5 squared plus, let's see, plus 80, I believe. Yeah, plus 80 times 2.5 plus 3. Okay, now we can compute this using our calculators. Bring our calculators out. So let's see, we're going to do, clear this, clear that. Negative 16 times 2.5 to the second power plus 80 times 2.5 plus 3. Okay, and the answer is 103 feet. All right, so 103 feet. So what does this mean? Let's put all our answers in a sentence. So the ball, or the baseball attains a maximum height of 103 feet in 2.5 seconds. Okay, so there goes the answer. Now let's shift our attention to the B part of the question. It says, at what time will the baseball hit the ground? Okay, so when will the baseball hit the ground? So since h of t is the distance of the baseball from the ground, when the baseball hits the ground, the distance from the ground of the baseball is 0. Okay, so what we're going to be solving is we're going to solve h of t equals 0. So if we solve this equation, that will tell us when the ball hit the ground. All right, so let's see. H of t is negative. We know what h of t is, right? H of t is the original problem, negative 16t squared plus 80t plus 3. So what we're going to do now is set that equal to 0. Let me just check to make sure it's right. Set it equal to 0 and solve. Okay, so negative 16t squared plus 80t plus 3 equals 0. All right, so let's go ahead and solve this. Let's go ahead and make use of the quadratic formula here. So I'm going to use the x. Let's figure out what a, b, and c are. So in this case, a is negative 16, b is 80, and c is 3. Okay? You can do this by factoring, but it looks like it's not going to be possible to generate a pair that will work. So this is a prime expression. All right? So let's use the quadratic formula. So we have t is equal to, we know what the quadratic formula is. Let's write that on the side here so we don't forget. X equals negative b plus or minus the square root of b squared minus 4ac, this whole entire expression over 2a. Okay, so that's what we're going to be using here. So let's do it. We're going to have negative b, which is negative 80, plus or minus the square root of b squared, 80 squared minus 4ac, 4 times negative 16 times 3. And that entire expression divided by 2a, 2 times negative 16. Okay, so let's work this out in a calculator. We'll have negative 80 plus or minus. Now let's evaluate this entire radicand expression here. 80 raised to the second power minus 4 times the negative 16 times 3 is 6,592. All right, so it's going to be the square root of 6,592, and that divided by negative 32. All right. All right, so let's split up our answers and see what their approximate values are. So we have the positive and negative piece, right? So we have, again, negative 80 plus the square root of 6,592 over negative 32, or we have negative 80 minus the square root of 6,592 over negative 32. Okay, if we divide by negative, this negative to the top of both of them, this one is going to become minus over minus makes that a plus, plus 80. And then this plus becomes a minus, minus the square root of 6,592. And then this other one over 32. All right, and then we'll find the approximate value in a minute. And then the other answer is 80 plus the square root of 6,592 over 32. How did we get that? If we divide this negative to the top, then this minus changes the sign of the numerator to a plus, and this minus changes the sign of this to a plus, and that's a minus. All right. So remember, we're doing a time calculation here, so only the time that's positive that actually counts. All right, so we can clearly see that this is an answer for sure because it's going to be positive. Well, this probably not so much, okay? So this one we can see that 80, if you square 80, you're going to have 6,400, and that's smaller than this, so this is going to be a negative value. All right, so this is not an answer. The correct answer will be this right here. So let's figure out what the approximate value is. So let's enter in our calculators. 80 plus the square root of 6,592 divided by 32, and it's 5.04 to the hundredth place, so it's 5.04 seconds, okay? And then let me show you that the other one is negative, so let's go ahead and verify. So if I compute the other answer, minus, enter. Wait, let's do it, the approximate answer. Okay, negative 0.04. Okay, so negative 0.004 seconds. But time can only be positive, so this answer doesn't make any sense. Negative time doesn't make sense, only if you can travel back in time. But we can't do that yet, so this is our answer right here. Okay? So what does this answer mean? Let's put it in a sentence. It takes the ball, the baseball, takes the baseball 5.04 seconds to hit the ground. Okay? So that's where there you go, to hit the ground. All right, let's take a look at two more problems. This one is mainly for pre-calc. All right, so the first one involves finding inverses, and then the other involves asymptotes. Okay, so for question number 5, find the inverse. Find the inverse of f of x equals 2x plus 3. Okay? All right, to find the inverse, what we'll do here is we're just going to rewrite the function as y equals 2x plus 3. We're going to switch the x's and the y's and then solve for y. Okay? So we switch the x's and the y's. We have x is equal to 2y plus 3. All right, and then let's isolate y. When we isolate the y, that will be the inverse of this original function. Okay, so to do that, we'll subtract 3 from both sides. Subtract 3. Using the reflexive property of equality, we'll have 2y is equal to x minus 3. And then divide both sides by 2. Okay, so divide by 2, divide that by 2. And your resulting y will be your f inverse. So f inverse of x equals x minus 3 over 2. All right, so that's how you find your inverse. All right, let's take a look at the last problem. Question number 6. It says, which function matches a graph? So let's take a look at the graph of this rational function. We can clearly see that there are two asymptotes present. Okay, so we have a vertical asymptote through -1, and then we have a horizontal asymptote through 1. Okay, so let's write that information down. So from the graph, we can see that we have a horizontal asymptote of y equals 1, and a vertical asymptote of x equals -1. All right, so let's look at the options here. In option A, this option A has a horizontal asymptote of y equals 1. How do we know that? Because they're both equal weights, right? So if it's equal weights, what do? You divide x over x equals 1. So your horizontal asymptote is 1. And in this one, your vertical asymptote is x equals -4. How do we know that? Well, if you look at the denominator, nothing reduces, so we set the denominator to 0. X plus 4 equals 0. And then when you solve for x, you get -4. Okay, so that's for option A. That's not what we have here. All right, let's shift to letter B. For letter B, the horizontal asymptote is y equals 1 again, because they're both equal weights. When you divide the x's, you get 1. The vertical asymptote is what? The vertical asymptote is x equals -3, because when you subtract 3, you set this one to 0 and subtract 3, you get -3. Do we have a match? No. All right, let's move on to the next equation. C. For this one, the horizontal asymptote, they're both equal weights. When you divide leading coefficients, you get y equals 1. A vertical asymptote is x equals -6, because when you set the denominator to 0 and solve, you get -6. That doesn't work also. Let's look at the last one. That should be the correct answer. So for the last one, the horizontal asymptote is y equals 1. Because it's equal weight, so you just divide leading coefficients. And then the vertical asymptote is x equals -1. When you set it to 0 and add 1 to both, subtract 1 from both sides, you get -1. And that is perfect, because that is the situation with this graph. This graph has a horizontal asymptote at 1 and a vertical asymptote at -1. All right, so there you have it.